Hello, the listener. This is M. Solomon Enterprise. We are back again with another video. And in this lesson, we will learn about types of fault findings. So we will create our own faults from this sketch that is given here. So we did a random sketch in which we'll show you how to find a fault when we create it in a coil of a contactor, and we'll create a fault in a coil of delay on timer, and we'll create a fault in a delay off timer, delay on timer and delay off timer. Right. So we chose these three coils because of they are different from each other, and also their contacts. Their contacts, they are different from each other, and they react the same. They don't react the same, right? So since well they don't react the same, we have to know how to test them when we are given a fault. So in this lesson, we will show you the easiest way to trace your fault in your panel, referring to the sketch that you are given, right? So we'll use this sketch as a sketch that is given, and also we'll use it as as our panel, right? So firstly, when you do fault finding, when you're given a test, so we'll show you how to test your supply voltage, to check if your supply voltage is correct or not correct, right? So we'll use a multimeter as our multimeter. So to test our supply voltage, so we will put it in continuity test. So our supply voltage will be off because of when we test our circuit, our supply voltage must be off, right? We shouldn't test when there is power in the circuit. You must make sure that everything is off and there's no power to the circuit, so that you can start to test your circuit. Because of if you can test your circuit with the power that is switched on, it will affect your multimeter to make a reckless beep to show that it doesn't allow the multimeter to test the wires while they have the supply voltage, right? So you must switch off everything, and when you are given when your sketch has also bulbs in them, you must take out those bulbs and test when you have took off all the loads from the circuit, right? So we put our multimeter in continuity test, and we will test our supply voltage, which is live 1, neutral, and earth. So this is the single phase supply voltage. So remember, our supply voltage is off from the dB box, right? It's off, so there's no power in these three wires of single phase, right? So we'll test live 1 and neutral to check if live and neutral, they are not connected or connected. So if they are not connected, then we are good. And if they are not connected, if they are not connected, we are good. And if they are connected, it simply means that is our fault, because of live and neutral shouldn't be connected to each other, right? You also test live and earth, right, to check if they are connected or not connected. So to be right, they must not be connected to each other. and also you must check neutral and earth to check if they are connected, right? So we must confirm life 1, neutral and earth, from where the supply voltage starts to where it ends, right? To make sure that all the circuit, our life, our neutral, and our earth, they are not connected to each other, right? Okay, so when we test life here and neutral here, it's the same as we have tested here from here, and neutral here from the until the neutral bar, and from the neutral bar until the from the point from the voltmeter from neutral side, and also until all the A2s of the coil. When we have put our lead here and lead here, we have tested the point that we have shown you, and then we will switch on our circuit breaker. This is our circuit breaker. We'll switch on our circuit breaker so that our live can flow all down, so that we can test the live from here until in which it will flow here and goes to the points that ends, right? So we'll check what has happened to live after we have switched on the circuit breaker to be closed. Our live current will flow down once close contact, will flow down and also go to the voltmeter, and also go to the close contact of overload relay, which means current will flow. Emergency stop, close contact, current will flow. Stop button, close contact, current will flow. Current will be trapped here and be trapped here, right? So which means our live current is trapped here and here, right? So I put my live here and my neutral here, right? I'm testing if they are connected to each other. The insulation resistance test between conductors, right? So when I put my leads here and here from the scale of continuity test, it's the same as I've tested here. It's the same as I've tested the live from here to here to here to here, with the neutral from here until here and until all the A2s. So from there, our live and neutral shouldn't be connected to each other to show that they are right? So also we want to test our neutral from we want to test our neutral with the live from where it starts to where it ends. So secondly, our live has ended here before the start button and before the retainer of coil or of the retainer of contactor, right? So when we want to test our neutral with the live where it ends, since we have the start button in which we can push to create close contact, so we'll push our start button to create close contact and hold it like that, right? And put your leads from where the live starts and neutral, right? So let's check from our live. Our live current starts from here and ends from here, and also it was ending from here to here, right? But since we are holding our start button, down, it means also our current flows until here and until here and also until here, right? So when I test my live current from here and my neutral current from where it starts, is the same as I've tested my neutral with the live until here and until here, until here and until here, right? But if you can check from here, we have a close contact, which means current will flow, and all the way to A1. So is although this the same way as we tested neutral from here until the life from here, and here, right? Because of here we have the normally open contacts, right? So it's the same as we tested live from here and here and here, with the neutral from here, 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 and here, right? So our wires shouldn't be connected to each other, right? So if we can check, the contact of delay of timer is open, and the contact of contact of a contactor, it is normally open contact, right? So for the normally open delay of timer, we cannot press something to create a close contact here, right? This contact of delay of timer will only be affected when the timer of delay of timer, it is activated, right, or deactivated. That's where this normal open contact of delay of on timer will be triggered. So we cannot push anything to let the current to flow until A1, so that we can test from here until here, right? So right now our live current is trapped here, here, and the A1 of coil of delay of timer, right? So to check our live current from where it starts until this A2, since when we have tested live from where it starts until here, here, and here, and from this contact, if we cannot press anything, which means we'll put neutral, and we'll put from live after the normal open contact of delay of timer, right? From here, which means we have tested live from here to here, with the neutral from here, here, and all the A2s of the coils, right? Which means our life from where it starts until A1 of coil of contactor, with when we test it with a wire of neutral from where it starts to where it ends, it shows that it's not connected, to show that it is right. It's a right connection, right? These two conductors shouldn't be connected to each other, to show that the sketch is right? And also you have to proceed from here. So from this normal open contact is a normal open contact of a contactor, which is 53 and 54. But from the normal open contact of a contactor, we can press a button whereby when the coil is energized, the button of a contact of a contactor will be pushed inside, right, when it has power. But even when it doesn't have power, we can still push that button manually, so that it will create a closed contact, right? So remember, we are still pushing our start button, and also we pressed our button from contact of a contactor, right, in which it created a closed contact, right? And when it has created a closed contact, it means right now our life starts from here, ends here, and will pass through the close contact of a contactor and all the way to the A1 of delay on timer, and also until A1 of delay of timer, right? So when I put my lead here and here, the same as I tested my live from here, 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 and with neutral from here, 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 and here. So in which it shouldn't give us the reading, or it shouldn't beep to show that the two wires are not connected to each other, right? So if you find that the two wires are connected to each other from where you have tested, so it simply means you must disconnect them from where they are connected and connect them in the right way, right? So right now we will test our neutral with earth. We have tested live with neutral. Right now we test neutral with earth. We put earth here the same way as we are testing here, neutral bar, and to the last point of earth, right? With the neutral from here to the neutral bar to the voltmeter, A2 of delay of timer, A2 of delay on timer, and A2 of coil of contact, right? It's when we have put it from where it starts, and also from where it starts from the earth, right? So they shouldn't be with each other to show that the sketch is correct. So we are done with neutral and earth. So we'll test earth and live. You do the same thing. You switch this on, you press the start button, and then you press the contact of a contactor. You press that button inside, and also test like this. And when you test live and earth, is the same way tested live from where it starts to where it ends here, and also it ends here, and also it ends here, and also it ends here, right? And after, you have to proceed after the normal open contact of delay of timer, because of we cannot push any button to trigger this contact to bit loose. So we'll test it after the normal open contact of delay of timer. Here it's the same way as we tested here and here, and earth from where it starts to where it ends. So in which it shouldn't give us the continuity to show that the two wires are not connected to each other, right? So the quickest way it was to put the first lead from where it starts and put it from where it ends and press the start button, so that it will be easy for you to trace the live wire from where it starts to where it ends, than to test the wires one by one. So this method, by putting the lead from where the live starts to where it ends and pressing the start button, is the quickest way to do your fault finding very fast, right? It saves a lot of time. So you have to understand how to do your fault finding in the quickest way, so that you can save your time when you got your fault from the sketch, right? Also, without using the start button, you can also use the retainer, right? You can also use the retainer, because of, even if you press the uh, contact of a contactor, it will close this contact and also closes the retainer, which is number 13 and 14 in your contactor, right? So we can also press that button to close the retainer, and also the normal open contact of a contactor, which is number 53 and number 54, right? We can put our live here, and also from where the live ends, which is here, it will still beep, because of our live current will flow through the retainer and all the way until A1 of delay on timer, and also A1 of delay of timer, right? And this one, you'll test it alone, because of you cannot push any button to trigger this contact of delay of delay of time, right? Right, so now let's create our own faults through this sketch and see how we can solve them, right? So let's put everything back. Right, let's say you've done doing your connection and you said you've tested everything and everything is right. So you press your start button in your panel, create close contact, and when it creates close contact, your live current will flow down and be trapped here and also be trapped here, and from this wire it will flow because we have close contact of delay on timer, which means current will flow all the way and energizes the coil of T2 because it will get live and also neutral from A2, which means it will be on, and when it's on it will affect its contacts. Okay, its contacts become closed. We are good. And when it becomes closed, which means current will flow all the way to the coil of a contactor from A1, and A2 it will also get neutral, which means it will be on. And when it's on, it has to affect its contacts, but after we press the start button, it becomes on, and when we let go of the start button, it becomes off immediately. And when it becomes off immediately, delay of timer will become off and its contact will become open again. So if you press your start button and coil of a contactor and delay of timer gets energized, and after letting the start button in which it will create close contact, your coil and your delay of timer gets energized same time. So the reason can be that it simply means your retainer of a contactor is not holding the current after the coil of a contactor is energized, because of to show that the retainer of a contactor is present. After pressing that button, the coil of a contactor must be energized and the coil of delay of time must be energized, in which it has to affect this contact to be closed, and after letting the start button go, in which means the current must be holded through the retainer of a contactor so that it can supply from where it supplies, right? So if you can get that fault whereby you push the start button, a coil becomes energized, and after letting it go, it becomes off immediately, it simply means there's no retainer that holds the current after pressing the start button, right? Which means your fault, you have to trace your fault from this wire until number 13 of the retainer, to see if it's absent or present, right? So let's say it is present, and then also you have to test it after, which is number 14 from this wire. So if this wire is absent, which means you'll take this wire like this to show that it's absent. So which means our fault will be from number 4 out. You will say is number 4 out of the output of start button, and also number 14, which is the retainer of a contactor. So this is where you got your fault. You'll write it like this in your sketch that will be given to trace your faults and mark it in the sketch that will be given. So this is how you'll mark it like this and write from number 4 to number 14. So which means is this wire, right? This wire is absent. That's how you'll do it. Right, so let's move to the next fault. So let's say they give you another fault and they say let's say you press the start button, right? Current flows all the way to the coil of delay of timer, in which will become on. When it becomes on, it affects its contacts immediately, right? Its contact will become closed, and then let the current flow all the way to A1 of coil of contactor, and coil of contactor will also get A2, right? It becomes on. When it becomes on, it affects its contacts. Here it becomes closed, and according to the sketch, here it must become closed, but our delay on timer does not get energized, right? So if our delay on timer does not get energized, it simply means you must check from the normal open contact of a contactor, from the in point and the out point. That's where you'll know where is your fault, right? So you'll check from the in point. Okay, we'll let go of your start button. The coil will still be energized with the retainer, right? So you test from out of the retainer to, which is number 14, to number 53, which is the in point of the normal open contact of a contactor. And if it beeps, then which means this wire is correct, right? So you test from the output of the normal open contact of a contactor, which is number 54 in A1. So if you get that it doesn't beep, which means you'll highlight it to show that our fault is here, and you'll write that your fault is between point number 54 and A1 of coil of timer, a delay on timer, right? But from the sketch that we have used here, our fault is between the numbers of the components, but from your sketch will be from the numbers of numbering that that you'll be done, in which it will be number 1, 2, 2, 2, 2 until the last numbering. So from our side, we just show you with the numbers from the components, not from the numbering that you'll be doing, not from the numbering that you'll be doing from your sketch, right? So there's your fault, then you'll mark it like that. So another thing that you must be careful with is when you connect your wire, maybe in your bar, your neutral bar or your S bar or your circuit breaker, you must make sure that your wire is connected correctly to the right point, and it is connected, the bolt, it is connected to the copper of the wire, but not the insulation of the wire, right? You must connect it to the copper so that it can be present, because of if you can connect it to the insulation and test continuity, it will tell you that the wire is absent, and that will be tricky for you, because of you'll see that the wire is connected, but you won't know that the wire didn't touch the copper. So you must be very careful about that one, right? Make sure you do your connections right. Right, so that's another fault that you can find. So all in all, about fault finding is that you have to know the operation of your sketch and the operation that you'll get when you test your panel, right? So if the coil of a contactor is not energized, check the connection that only affects the coil of a contactor not to be energized, right? And when the delay on timer is not energized, check the connection that can affect the delay on timer not to be energized. Only the connection of delay on timer. So the readings that you'll get when you test your panel, when you operate it, are the readings that must correspond with the sketch that you are given to do fault finding. So where your panel misses its operation, you have to know from the sketch where is that operation supposed to be happening, right? And that's where you'll know where to test, which connection to test. So the sketch and the faults that you'll get will direct you to correct your panel to be correct. So that is it about fault finding. We hope to find questions about fault finding, because we know that a lot of people make mistakes and they end up not knowing where to trace their faults. So ask us any questions about the faults that you got, and we will help each other to tackle them. So inbox us in WhatsApp, in contact 068 068 050 sorry 0506451. This is 0. So contact us here, inbox WhatsApp, so that we can assist you with the faults that you got while practicing. Right, thank you. That's it about the types of faults that you might find in your sketch. Catch you in the next lesson. Bye.